Hey guys, my name is Esther. I'm one of the tutors here at Tutor. And today we're going to be going over the first question of the 2018 AP Chem exam. I'll run through each of the questions step by step. If you have any questions or comments, leave them below. So let's get started. Here we have the first question of the 2018 exam. So let's get cracking. A student performs an experiment to determine the value of enthalpy change of the reaction represented by the balance equation above. Determine the oxidation number of Cl. So the oxidation number is essentially the charge of that element when it's in that compound. So we know that the overall charge is neutral because there's no charge stated. Therefore, we know that the charge of Na plus oxygen plus chlorine has to equal to 0. Okay, there's only one of each, so the charge of sodium is +1, plus the charge of oxygen, which is -2, plus the charge of chlorine is equal to 0. Those put together are equal to -1 plus Cl is equal to 0. Therefore, the charge of Cl is equal to +1. There's your answer. All right, option B. So, calculate the number of grams of Na2S2O3 needed to prepare that solution. So what we do first is figure out the molar mass of that compound. So we have Na, which is 23. We have 2 of those. We have to times it by 2. So we have 46 grams. For the sulfur, you have 32.1 as your molar mass. Once again, we have 2 of them. So that is equal to 64.2 grams. And then you have your oxygen, which is 16. And we're timing that one by 3, so we get 48. In total, all that together, we get a total of 158.2 as our molar mass. So from there, we can start to calculate the number of grams that we need for the solution. So I start with what we want. So we want to end up with 0.1 liters of Na2S2O3. Okay, because we want to cancel out our units, we're going to times by the molar, the concentration that we want, but we want to have liters on the bottom. So we'll have 1 liter down there, and then we know that 0.5 moles of Na2S2O3 on the top. Okay, so that liters and that liters has canceled out. Now we want to end up in grams, so we're going to want the moles to cancel out. So we know our molar mass is down there. So if we put 1 mole on the bottom, we know that that is equivalent to 158.2 grams of Na2S2O3. Then those moles cancel out and you're left with grams. Plug that into your calculator, you get 7.9 grams. So we know that you need 7.9 grams of Na2S2O3 in order to prepare a solution like that. So next, using the balance equation and the information in the table above, determine which reactant is the limiting reactant. Justify your answer. So from the table above, we are shown that they're using the same concentration and volumes of each of the 3 reactants. So we have to think then which one is the limiting reactant. So which one's going to run out first? And we can figure that out by looking at the coefficients. So every time the reaction goes by once, it uses 1 mole of Na2S2O3 for every 4 moles of NaOCl and every 2 moles of NaOH. Therefore, we could easily see that the NaOCl is going to be a limiting reaction because you require more of it for each mole reaction. So we could say that NaOCl is the limiting reactant because more of it is required per mole reaction. Therefore, it will run out first. Okay, so moving on. That's the same reaction up at the top there. And they're giving you a graph. They're saying that originally the experiment was at 20 degrees Celsius, but they recorded the temperature as the reaction occurred, and by the end you're at about 32.5 there. So you're just under 33. So according to the graph, what is the temperature change of the reaction? So change in temperature is equal to the temperature final minus the temperature initial. From the graph, we can say that the temperature final is 32.5, and the question tells us that originally it was 20. Therefore, the change in temperature is 12.5 degrees Celsius. Okay, now E1. So now they're telling us the mass of the reaction mixture inside is 15.21 grams. Calculate the magnitude of heat energy that's released. So from data booklet, you know that Q is your heat energy, and that is equal to mc change in T. So m is your mass, which is given, so 15.21. C is your specific heat capacity, which is given as well. That's 3.94. And your change in temperature you just worked out is 12.5. Okay, and plug that in and you get 749 joules. So energy is in joules. So number 2. Using the balance reaction and your answer from part C, which was basically saying that this guy here was your limiting reactant, calculate the value of entropy change of the reaction in kilojoules. Okay, that's important. We need in kilojoules. Include an appropriate algebraic sign with your answer. So in order to do that, we know that NaOCl is our limiting reactant. So what we have to do is get that, figure out the number of moles that is created for that, and then convert that to mole reaction, and from there we'll be able to figure out the enthalpy change of the reaction, because you don't want the enthalpy change of the specific compound, you want it for the entire reaction. So first we have to do NaOCl produced. Okay, so we have 0.05 liters, which was given from the table previously, times 0.0 moles per liter, which is the concentration. So liters cancel out, so you're left with moles, and that gives you 0.0025 moles, okay, of NaOCl. Now we want to convert that to mole reaction. So the mole reaction for NaOCl is 4 of moles of NaOCl for 4 moles reaction. So we're going to take this. So we have 0.0025 moles of NaOCl times, so we said that was 4 moles of that. AOCl for 1 mole reaction. So those cancel out and you're left with your mole reaction, and that gives you 0.000625 moles. Okay, so from there we know that the change in entropy is equal to the energy over the mole reaction. So that is equal to entropy is, the heat energy given off is we found before, but we need it in kilojoules now, and we also need to write sign. So this is energy given off, which means that the energy is leaving the system, therefore it has to be a negative sign. And then when we convert it to kilojoules, it becomes 0.749 kilojoules over our mole reaction that is created, so 0.000625 moles. That is equal to negative 1.2 times 10 to the 3. And then your units are kilojoules per mole reaction. Okay? So last part of the question, once again, equations up at the top. The student repeats the experiment, but this time doubling the volumes of each of the reactants as shown in the table below. So the magnitude of enthalpy change in kilojoules per mole reaction calculated from the results of the second experiment is the same as the result calculated in part E, number 2. Explain this result. Why are they the same? So they're the same because you double the amount of moles used, which means that you also double the amount of energy produced. The amount of heat given off is the change in energy. So when you increase the input, you also increase the output, but the actual change is the same, which is why the enthalpy change is the same. So what you could say is that when you double the number of moles, you double the energy produced. Therefore, since the heat is the change in energy, it remains the same because the output and input were doubled. Okay, so last question. Write the balanced net ionic equation for the given reaction. So we want to separate all of these into their separate ions and then cancel out which ones are the same on both sides. So for Na2S2O3, we have 2Na plus 1 S2O3 2 minus. Okay, and then for NaOCl, you get 4Na plus 4OCl minus. Then 2NaOH, get 2Na plus 2OH minus. Then now for the products, we have 2Na2SO4. So once again, so it goes to Na plus, and we have 2 of them, but we have 2 of that compound. So that would be a total of 4 Na plus 2SO4 2 minus plus 4 Na plus 4Cl minus, and H2 is a liquid, so it doesn't break up into ions, just plus H2O. And then you have to go along and cancel them. So let's see, we have 2 NAs, 4 NAs, so that's 6, 8 NAs on the left-hand side and 8 on the right-hand side. So we can cancel out all of them because you have 8 on both sides. And then from there, there's nothing else that cancels out. So that will give you your final ionic equation. So S2O3 2 minus plus 4OCl minus plus 2OH minus goes to 2SO4 2 minus plus 4Cl minus plus H2O. Alright, that's your final ionic equation. So hopefully that all made sense. And that's the end of the first question of the AP 2008 exam. For watching, I hope you found this video useful. For more videos like this, please be sure to subscribe to our channel in the link to the right. If you would like some extra help, check out the link in the description where you can sign up for one-to-one sessions with either myself or another one of the members of our team. Thank you so much for watching and have a lovely day.